Today's video is on integration using residues. In today's video, we are going to evaluate an integral using residues. Now, in this video, we are going to evaluate integral 0 to 2 pi sine 3 theta by 5 minus 3 cos theta into d theta using residue theorem. See here, in order to solve this, first of all, we have to take z is equal to, so we have to put z is equal to e power I theta. Clear? And e power I theta is nothing but cos theta plus this value is I sin theta. So if I take modulus, this will be mod cos theta plus I sin theta. And therefore modulus of z is equal to, this value is cos square theta plus sin square theta. Clear? And therefore we got a unit circle, that is mod z is equal to 1. So this is a circle with center 0 and radius 1. So we got mod z is equal to 1 as the region. And the next thing here is we need sine 3 theta, d theta, cos theta, all the three values. See here, I am showing you. So again we have z is equal to e power I theta. If I make a derivative on both sides, then dz is equal to e power I theta is again e power I theta, and for I it's a constant, and for theta this is d theta. E power I theta is nothing but z. So this is zi into d theta. So I want d theta value. Therefore d theta is equal to dz by this value is zi. So we got d theta value as dz by zi. So we got this d theta value. So again I am going with sine 3 theta. So here sine 3 theta is nothing but as usual sine 3 theta is equal to e power 3 theta I minus e power minus 3 theta I by this is 2i. So this can be written as sine 3 theta is equal to, this value is z cube, e power I theta is z, so this will be z cube minus this is z power minus 3 by 2i. So this can be written as sine 3 theta is equal to, this value is z cube minus 1 by z cube by this is 2i. This value is 2i. Therefore, sine 3 theta is equal to, so if I take z cube LCM, this will be z power 6 minus 1, and again this is 2i. So therefore, sine 3 theta is equal to, this is z power 6 minus 1 by 2z cube into I. So this is our sine 3 theta value. And next one here is we need cos theta value. For cos theta, what we have to do? As usual, cos theta value is e power I theta plus e power minus I theta by 2. Clear? So cos theta is equal to, this is z plus this value is z inverse by 2. Therefore, cos theta is equal to z plus 1 by z by 2, and therefore cos theta is equal to, this is z square plus 1 by 2z. So we got cos theta value as z square plus 1 by 2z. So all the values are ready for substitution. So here if you see this, first we have to substitute sine 3 theta value, cos theta value, d theta value. So every value is ready. As I am writing on this, sine 3 theta value is very clearly, sine 3 theta value is, I am showing you, this is z power 6 minus 1 by 2z cube I. This is z power 6 minus 1 by 2z cube into I. And the next one here is cos theta value. So cos theta value is z square plus 1 by 2z. So this is z square plus 1 by this is 2z. And here d theta value is nothing but d theta value is nothing but this value is dz by this is zi, and the region here is mod z is equal to 1. Now I am going to substitute in this integral. So the integral here is very clear as integral 0 to 2 pi. So this is integral 0 to 2 pi this value is sine 3 theta by 5 minus 3 cos theta into d theta. If I substitute each and every value here, this will be integral 0 to 2 pi. Sine 3 theta value is nothing but this is z power 6 minus 1 by this is 2z cube I, and d theta value is nothing but dz by this value is zi by 5 minus this is 5 minus 3 into cos theta. So what is the cos theta value? This value is z square plus 1 by this value is 2z. Clear? Now I am going to solve this one. So here this will be integral 0 to 2 pi. This value is z power 6 minus 1 by 2z cube I into this value is dz by zi, and here if I take an LCM here as 2z, this will be 5 2z 10. This is 10z. If I multiply with 3, this will be minus 3z square, and this is minus 3. And therefore this value will be integral 0 to 2 pi. This is z power 6 minus 1 by this value is 2z cube I into this value is dz by zi into, so if I reciprocal it, this will be 2z by this value is 10z minus 3z square minus 3. Now I can cancel this one, z and z, and again 2 here and 2 here, and this will be what remains here. So this will be integral 0 to 2 pi, integral 0 to 2 pi, this is z square minus 1 into dz by this value is z cube, and this is I into I, this is minus, this is 10z minus 3z square minus 3. So if I send this minus inside, this will be integral 0 to 2 pi, this is z power 6 minus 1 into dz by this value is z cube into this value is 3z square minus 10z, and this value is plus 3. So what is our f of z here? So f of z is very clear as integral f of z into dz. So this is integral and this is dz. So the middle one is f of z. So f of z value is nothing but z power 6 minus 1 by this is z cube into this value is 3z square minus 10z plus 3. As you know that in order to find the poles, what we have to do? So we have to equate the denominator to 0. So if I equate the denominator to 0, this will be z cube into this value is 3z square minus 10z plus 3 is equal to 0. Here if I equate z cube to 0, so this will be 0. Z is equal to 0 is one pole, and here 3 3s are 9. So this will be 3z square minus 9z minus z plus 3 is equal to 0. So if I take 3z common, this will be z minus 3, and if I take minus common, this will be z minus 3. So if I take z minus 3 common, this will be 3z minus 1 is equal to 0. Therefore z is equal to 3 here, z is equal to 1 by 3 here, and here z is equal to 0. So these three are the poles. The poles here are z is equal to 0, z is equal to 3, and here z is equal to 1 by 3. So here, so we have to check z0. So z is equal to 0, z is equal to 3, and z is equal to 1 by 3 are the poles for the given function. So what is the region here? The region is nothing but the unit circle. The unit circle is nothing but it is a circle with center 0 and radius 1. So this value is minus I, this value is plus I. So this is the region, and in this region if you see 0 is within. So 0 is within the circle, and 1 by 3 is 0.33. So this is also 1 by 3. So these two are inside the circle, and 3 is outside the circle. So we no need to calculate the residue for this. So we have to calculate the residues for these two poles. One is 0 and one is 1 by 3. So here f of z value is equal to, see clearly there are two kinds. F of z value is very clear as z power 6 minus 1. So this value is z power 6 minus 1 by this is z cube into this value is 3z square minus 10z plus 3. So z value is this one, z cube into 3z square, or else it can be written as, or else this can be written as, f of z can be written as z power 6 minus 1 by this is z cube into, here the factors here are z minus 3 into 3z minus 1. So these three are the factors. So first of all, 0 is a pole. So here z is equal to 0 is a pole of order, 3. So it is a pole of order 3. So for finding the residue, what we have to do? So we have to find the residue. Therefore, residue of f of z at z is equal to z naught is nothing but, this is limit z tends to z naught. This value will be d by dz. So this value will be 1 by m minus 1 factorial into d by dz power m minus 1 into this value is z minus z naught power m into f of z. Here our m value here is nothing but the order value. The order is nothing but 3 and the pole value is equal to 0. Now if I substitute here, then this will be the residue of f of z at point z is equal to 0 is, residue of f of z at point z is equal to 0 is nothing but, this is limit z tends to 0 1 by this is 3 minus 1 factorial into d by dz power, this is 3 minus 1 into this is z minus 0 power 3 is nothing but, m is nothing but 3 into f of z. F of z is nothing but z power 6 minus 1 by this is z cube into this value is 3z square minus 10z plus 3 plus 3, and therefore this can be written as limit z tends to 0, this is 1 by 2 factorial into d by dz square into this is nothing but, if I cancel this z cube, this will be z power 6 minus 1 by this value is 3z square minus 10z plus 3. Now we have to make two derivatives for this function, and again we have to substitute z is equal to 0. So this is of the form u by v rule. So this is u and this is v. So the derivative here is v square v u dash minus u v dash minus u v dash. So this will be limit z tends to 0. So this value is limit z tends to 0 1 by 2 factorial into d by dz times of, so this is v square. So this value will be 3z square minus 10z plus 3 whole square. So v I have to write for one time. This is 3z square minus 10z plus 3. And again I have to make a derivative for this. This will be 6 into z power 5 minus, again I have to write u here, that is 6 power z minus 1, and again the derivative here is 6z minus 10. Clear? And if I multiply, this will be limit z tends to 0 1 by 2 factorial into d by dz times of, if I multiply with this, this will be 18 z power 7 minus 60 z power 6 plus this value is again 18 z power 5, and if I multiply this, this will be 6 z power 7, and this is minus 10 z power 6, and this is minus 6z plus 10 by this value is nothing but 3z square minus 10z plus 3 whole square. So again if I multiply, this will be limit z tends to 0 1 by 2 factorial into d by dz times of, this will be 18 z power 7 minus 60 z power 6 plus this value is 18 z power 5 minus 6 z power 7 plus 10 z power 6 plus 6z, and this is minus 10 by this value is 3z square minus 10z plus 3 whole square. Now see, here I can write this as limit z tends to 0. This is limit z tends to 0, 1 by 2 factorial into d by dz times of. So if you observe this one, this is z bar 8 and this is also z bar 8, and this will be 18 minus 6 is nothing but 12, 12 z bar 7, and next one 6. So here this is minus 60 plus 10. So this will be minus 50, minus 50 into z bar 6. And next thing here is again single z. This will be 18 z bar 5, 18 z bar 5 plus 6z minus 10, minus 10 by this value is 3z square minus 10z plus 3 whole square. See, clear? So this value is clear. And now again we have to make a derivative for this. And again we have to substitute z is equal to 0. So this value will be limit z tends to 0, 1 by 2 factorial into. And this is of the form u by v rule. So if it's u by v rule, what we have to do? See, have some patience. This is 3z square minus 10z plus 3 whole square whole square. This will be power 4. Again we have to write v. This will be 3z square minus 10z plus 3 whole square, and again we have to make a derivative for this. This is 12 sevens are 84, 84 z bar 6. Next one 6 into 50, that is 300 z bar 5, and 18 5s are, this is 90 n into x bar n minus 1. So this will be power 4 and this value is 6. For constant this value is 0. Minus, we have to write u here. This will be 12 z bar 7 minus 15 z bar 6 plus 18 z bar 5 plus 6z minus 10 into the derivative for this is 2 into this is 3z square minus 10z plus 3 into again this is 6z minus 10. In this we have to see here from here till here. From here till here we have to substitute limit z tends to 0. So we have to substitute, replace z with 0. So replace z with 0. So this will be 1 by 2 into, see here, if you see here this is 3 square and here it is z0 z0 z0. What remains here? 6. And next one here is minus z0 0 0 0 0, and this is minus 10, and here there is 2, and here if you observe z is 0 0, and here this is 3 left over, and here this is minus 10 by here 0 0 0. This value is 3 power 4. Clear? So this is 1 by 2 factorial is nothing but 2. This is 9 into 6 minus minus into minus plus, and again this is minus 6 into 100. This value is 600 by 3 power 4. This is 81. Clear? And this value is half times of, this is 54 minus 600 by 81. So if I subtract, this will be half times of 546. If I subtract 54 from this one, this will be 46 by this value is 81. So again if I cancel, so small number and this minus, this value is minus. So if I cancel in two table, this will be 2 2s are 2 7s 2 3s are. Therefore residue of f of z at point z is equal to 0 is nothing but minus 273 by this value is 81. So if I cancel in 3 table, this will be 91 and this is 27. So we got the residue value of f of z, as this is an internal pole. At 0 we got the value as 91 by this is 27, and the next pole here is, so if you see the next pole here is, the first pole here is 0. At z is equal to 0 we got the value, and again with z is equal to 3 we need this. So for z is equal to 3 is an outside pole, so there is no need of this pole, there is no need of this pole, and again we have to calculate the residue point. See here, residue of f of z as z is equal to 1 by 3, so simple pole is nothing but limit z tends to 1 by 3. This is z minus 1 by 3 into f of z. See here, this is limit z tends to 1 by 3, z minus 1 by 3 into f of z. So what is the f of z here? So f of z is ready as this one. This time I'll take this one as z power 6 minus 1 by, this is z cube into z minus 3 into this value is 3z minus 1. So here this is limit z tends to 1 by 3. This is z minus 1 by 3 into z power 6 minus 1. So this value is z cube into z minus 3. If I take 3 common, this will be z minus 1 by 3. So if I cancel these two and substitute in place of z as 1 by 3. So 1 by 3 power 6 minus 1 by, this value is 1 by 3 whole cube into 1 by 3 minus 3. So this is 1 by 3 power 6 is nothing but 1 by 729 minus 1 by, this is 1 by 27. So if I take LCM, this will be 1 minus 9 by 3. And here there is 3 here. So this value 3, if I cancel, this will be 1 minus 729 by, this is again 729 down, and here this is 1 by 27 into this value is minus 8. So this, if I cancel, this value is 728 by, this is 729 into, if I send to the numerator this one, 27 into this value is minus 8. So here in which table I have to cancel? So this goes in, see here, as this value is 8 ones are 8, 8 nines and 1s. And here if you see in 27, 27s are 729. So this is minus 21 by 76. So this value is minus and minus got cancelled, and this is plus. Therefore, residue of f of z at point z is equal to 1 by 3. So we got the residue value as plus 97 by 27. So we have to use now residue theorem. So according to our residue theorem, now residue of f of z, residue of f of z at the internal pole z is equal to 0 is nothing but minus, this value is nothing but, this is minus 91 by 27. This is minus 91 by 27. And residue of f of z at the internal pole 1 by 3 is nothing but plus, this value is nothing but plus 91 by 27. So this value is nothing but plus 91 by 27. Now according to our this one, according to our residue theorem, by residue theorem, integral 1 by 2 pi into f of z into dz is nothing but 2 pi I into sum of the residues at internal poles. So here the residue value here, this is integral 0 to 2 pi. The value, the integral value here is, and let me show you. So this is a sine theta by sine 3 theta. See here, sine 3 theta by 5 minus 3 cos theta into d theta is nothing but 2 pi I times of sum of the residues is nothing but minus 91 by 27. Here this value is plus 91 by 27. So if I cancel this one, this will be 2 pi I into 0, which is equal to 0. Therefore our final answer is, therefore integral 0 to 2 pi, this value is sine 3 theta by 5 minus 3 cos theta into d theta value is 0. So this is also the most important question. Please practice and let me explain you for one time. See, first of all, this is given as integral 0 to 2 pi sine 3 theta by 5 minus cos theta into d theta. So as usual, we have to put z is equal to e power I theta. So after that, mod z is equal to 1. This is the unit circle with center 0 and radius 1. And here, if I take z is equal to e power I theta and derive on both sides, we got d theta value. So in order to substitute here, I've derived d theta value and again sine 3 theta value. What is sine theta? 3 theta, that is e power 3 theta I minus e power minus 3 theta I by 2i. So if I simplify, this is sine 3 theta value. And again cos theta. Cos theta value is nothing but e power x plus e power minus x by 2. If I substitute z here, this is z square plus 1 by 2z. So after getting all three values ready here, that is sine 3 theta, cos theta, d theta. Now I have to substitute in this integral. After substituting and solving, so we got f of z value as this one. So with f of z, if I equate the denominator to 0, I'll be getting the poles. Here are the poles, that is z is equal to 0, z is equal to 3 and z is equal to this one 1 by 3. As these are the three poles and the region here is mod z is equal to 1. So it is the region with circle with center 0 and radius 1. So 0 is inside and 1 by 3 is also inside and 3 is outside. So we have to find the residues only for the interior poles. The first thing is, so we have to frame this f of z as like this, and z is equal to 0 is a pole of order 3, and for order 3 this is the formula, and here 3 value is the order value 3 and the z naught value is nothing but the pole value. After substituting and deriving for twice, so we have derived for 2 times, the first derivative here and the second derivative, and after deriving we got the value as minus 91 by 27, and the next pole here is 1 by 3. So here is 1 by 3. For the pole z is equal to 1 by 3, here is the formula, and f of z is this one, and after cancelling and after taking 3 common and cancelling, so substituting z as 1 by 3, we got the value as plus 91 by 27. So here for z is equal to 0, we got minus 91 by 27, and z is equal to 1 by 3, we got plus 91 by 27. So we have used the residue theorem, that is 2 pi I into sum of the residues of the internal poles. That is, after adding up, we got the value as 0. So this is how we have to solve. Thank you so much for watching and staying till the end. This is the most important question. If you follow all the videos in the playlist, definitely you can solve any problem of this kind, and kindly pass it on to your friends and subscribe to this channel and support. Thank you so much.